Okay, welcome everybody to this video. We are going to be talking about the systems design of debuffs and buffs. So first they are actually denoted quite commonly like this, so that you don't have to say buff debuff, right, like in text. And essentially the reason why this video was born is because we are working on something very similar in our game in Odyssey of Tremedier, which you can wishlist, and we also have a demo up. But I've noticed that the gamedev YouTube atmosphere barely touches on this topic in detail. So by just using this project, I want to walk you through the very basic constructions and interesting obstacles of designing a system like this. So first, we need to look at the types of debuffs that we could have. And I typically like to say that there are three types. So the first one is gonna be, that's a bit obvious, there's gonna be permanent effects, right? Where you just like say that, hey, this guy gets 5 HP and the whole interaction is just done there. The second one is temporary, and this is a bit more interesting because you need to roll this effect back at some point, be it a flag or a timer or whatever like that. These kind of effects get applied once, just like permanent debuffs or status modifications, but again, the key difference is that these get reverted. And we're going to discuss how as well. The third type is sticking effects, where they happen a certain amount of times under certain conditions. They happen X times under Y condition. So we could tie this to seconds, right? If I say that I have a ticking stat modification that I want to go for 5 seconds, and we should remove one of the stat, like HP, 1 HP per second, this would result in 5 health points being lost in general, right? When the debuff is actually over. And these typically do not get reverted. The gimmick of the ticking stats is only that they happen more than once. And that's what makes them a bit special, so to say. Now, something pretty important is that the modifications may or may not only be character stats explicitly. So the modified value, because this is a common misconception when designing systems like this, and again, this is specific to games, right? So it's a bit circumstantial, but modified value is not only an explicit stat like HP. It could be a restriction flag, right? It could be many things, really. First time we were designing Odyssey and we fell into this trap. We originally had all our stat values, so HP, mana, power, all those things. But now you can kind of see the division line after evasion, even, that we start to have other types of stats.
And these also have a different naming convention, right? You can see that they are not capitalized and set up in a fancy way. And the reason for that is actually we store our stats in an array. So we have a stats array and other variables. And this just leads me back to this statement where the modified value is not only an explicit stat. So the one mistake we made was just not thinking about this ahead of time. Luckily, it was fairly easy to redesign this system and like get around it by saying that upon modification, basically what we were doing with the stats array was that like we were indexing that array with a stat index and just, you know, manipulating that. But now we have a base stats enum as well, so that covers our natural stats that I've mentioned here from HP to evasion. And then if our stat index, stat is a bit ambiguous here, so we could call it variable index, right? Let's go just simple variable index or something like that. Now, if the index is larger than our stat size, if it's more than or equals to the stats, our stats enum size, because we use an enum for this, a base enum. We even have a stat script, but it's pretty outdated. But anyways, yeah, we have this base enum, and this has all these stats that we can use, and it's also used to look up inventory logic, many things like that. But so if this index goes basically out of bounds of the enum, then we just straight up do get, the get function call. And then we plug in the var key, right? And the var value, because Godot specifically has this sorry, not get, set is what I meant. But well, we also use get, and we'll talk about that in a bit. But Godot has this set value and also the get in every class, and essentially it just lets you set or get variables by their name. And the reason why I said var key here is because I mean the key that is being displayed here, like all these texts. So if I pick weapon roll damage, since this is not a natural stat anymore, now we will just plug this variable name in straight up into the code, and we just modify the variable named this, because we literally store our variables like that with this name, if that makes sense. And this makes the system pretty scalable, right? Now that we have something like this. With stats, it was pretty rigid, and we had to do workarounds. But now we have the freedom of just doing this. So that's it for the types of stats and the variables we can mess around with. But how do we actually set the value, right? So how do we express the value is the question. So this also has three ways.
and the first one is just like addition, right, or subtraction. So if I say +3, if we have the HP of 10, and then we do +3, it becomes 13, right? But we can also say percentage. So if I say plus 50%, this would just make it 15. And the third type is what we call assignment. I'm not sure if there's a better way to call this, but assignment just straight up sets the variable to the number we give it. And now if I say just 20, our HP will become 20. And to express the value, we actually have some other things called modifier stats or modifier variables even. So that is applied here. Yes, multiplier stat of user. We haven't had the need to extend this onto the two other modification types, but essentially here we can plug in a type of stat or variable of the user and also have a plus percentage per multiplier stat value. So if I say I want this buff that is being applied, let's say on an ally, if I set the multiplier stat to be the power, and I say that our calculated value here, if I wanna do plus 10 HP, then if you have this multiplier stat, and I say that the plus percent is gonna be like, let's say 5, then if the user has the power stat of 4, then that means we get this 10, right? We have this 10 that would be added as a constant value addition, and since we have this power thing I mentioned, if we have 4 power and we add 5% per this multiplier stat value of the user, that means 4 times 5, right? I'm just gonna type it here as well, or like just sketch it up to give you a visual idea. So if our default state is plus 10 HP and our multiplier stat is power, and percent per multiplier stat is 5, and then the user has 4 power. This means we will apply 10 HP plus let's do it like this. Plus 10 HP times 0.05 we don't need the parentheses there, right? It doesn't really matter, but just to make it cleaner. Yeah, let's order it like this. The order of operation doesn't matter for multiplication, but just to let you see the idea behind this. So we have the default here, and this shows this percent per multiplier stat of user variable that we have in Godot. So this is the quantity we add per stat. Quantity per stat of 1 unit. And then after that we just apply this constant, right? It's 4 from here. And this is how we can further diversify our values and the value that is being applied. So we have talked about flags, right? Flags for when the stats expire. And there can be a whole lot of them actually. Also, you need to consider stacking. It's also really important to like mark a buff or debuff as completed. So how do we reach completion then? First, we pick a flag, right, that can say our debuff has been completed and the effect is done. We may also want to revert it, obviously, you know. It could be a timer, the fight being over as well, or a turn being over. Just to name some examples. You can also see here we have some of these. And you may also want to set up custom signals, because essentially the way we set up these flags and connect the logic is we use signals at the end of the day, but just awaiting those signals alone won't do, because we have multiple ways to mark the completion of a buff or debuff. And so the flag is the first one. Now the second one is, it could be respawning. But let's handle it a bit differently in our code base, because we keep the timestamp of when the certain character was respawned as a variable, and then once the debuff would expire, then we just check if the respawn has happened since the beginning of the buff or debuff application, and that way we can just decide if we want to revert our effects, because when we despawn we also already like remove some certain effects that are supposed to last while you are alive, and that can actually bring us to the flag of dying as well, right? So when you die you want to revert certain things, but the third flag is like curing a particular debuff with an item consumption or something like that. And so because of these two mainly, we have a new script set up, a new class that we use to like simultaneously listen to two different signals. And then once either is emitted, then we just take this new script signal that will be fired when either of these signals get emitted. So for example, if we have the timer flag of like 10 seconds, and we also need to account for curing this effect, this new script will listen to both of these, right? And this new script, it will produce a unified signal that we can listen to and revert the effects properly. The last interesting thing is the way you have to account for the same effect being present in your combat or whatever on multiple characters. Because if you do this with a resource, and this is gonna get a bit Godot specific, but this applies to Unity's scriptable objects as well whatsoever. But having the same effect on multiple characters is pretty troublesome. And the reason for that is, let's assume that you store something like a uncured signal. You have a uncured signal or a cured signal, however you want to call it. Let's call it cured signal. Now, if you emit this when a character gets cured from this debuff in question, then, and this is awaited by our new script that sends this unified signal on either the flag being over or getting cured. This is gonna trigger ending the debuff on both characters, right? So this can cause conflicts even. To resolve this, you could add the signal parameter so that the script only throws the signal if you are curing the certain character you've given to the script with the signal. And then if you want to store something like the recent effect or a counter or something, let's stick to a counter. If you want to store like And by this resource being shared, the resource of the actual effect, it will result in an issue to give a unique effect holder to each character if you would ever need that. Because if you have a certain kind of debuff, one that makes you bleed, and you just use the same debuff on two characters, you're not gonna be able to uniquely identify what debuff or which debuff instance you have rather. So for such use cases and in certain scenarios, you would want to duplicate the resource to avoid having the literal same instance on multiple characters, and that can solve you this issue. And you can also get around a bunch of things with doing the signal parameter approach. That is also really good. Of course, with this new script, we actually call it yield listener. In Godot 3, we still had the yield keyword instead of await, but like, you know, the logic is the same. So that's basically it for this brief video, and I hope you enjoyed this talk and could learn a bit about systems design. If you have any input, then feel free to share it with us. I'll be happy to read any feedback on how you design your game and its debuff system. Thank you so much, and make sure to subscribe and like this video if you enjoyed it. Goodbye.